Here is a little Airfix 042 engine that I bought for a project. Yeah, I know the Airfix ones have a reputation for not being terribly good, but as I wanted to hack it around, I wanted a cheap loco that I could hack around without losing too much money. Anyway, this one doesn't run very well. Or it didn't run very well when I got it. Essentially it sat doing nothing until you turned the regulator almost full up, and it would suddenly leap away, and it was absolutely rubbish at low speed operation. So I took it apart, cleaned it, serviced it, put it back together again, and it was doing exactly the same thing. So the problem is that the magnet in the motor has become weak over time. These are very old locomotives. So let's have a go at trying to improve the magnet. So I've hooked the motor up, running it through an ammeter so we can see how much current it's drawing. Let's go. It takes half an amp to start it. In the opposite direction, it doesn't seem to want to run itself, and it's taking most of an amp, which is not good. No, I'm not going to run it too long like that, because it is getting quite warm. Let's see what we can do. So here's the culprit. This is the magnet out of the motor, and it's pretty weak. It doesn't really want to lift that screwdriver. And here I have a stick of neodymium magnets. Now, there's a lot of talk recently about using neodymium magnets to replace the existing magnets in motors, and that they're just too strong for the purpose. So let's not do that. Let's use them to remagnetize this. So if I find the north pole of this magnet, which is quite nicely marked by that big chip out of it, I take a stick of neodymiums and find the south pole of that, and then attach it to the north to south, split it in half, connect the other side. So now I've got my voice is going. So now I've got the magnetic flux running through the old magnet. Move those around a bit. I should really tap that magnet with something non-magnetic. I don't have anything non-magnetic. If I try that, it's not too bad. Just to shake the demands around a bit. I think that should do. Take it off and put it somewhere safe. And then we should have a stronger magnet. So let's try that back in the motor. So let's break for a minute and have a look at some of the theory to try to explain what I'm trying to do here. The magnet in that motor is made of a ferromagnetic material, and these are comprised of a number of magnetic domains. In their natural state, the magnetic fields within the domains are in a completely random order, some of them coming out of the page, some of them going into the page, but the overall effect is that they cancel out. When a ferromagnetic material is magnetized, all of these fields are aligned in a particular direction, in the same direction. So that at one end, for example, we would have a north pole, and at the other we'd have a south pole. What happens then over time is that due to expansion and contraction, due to heating and cooling, or sudden impact, the atoms within the domains can move around, and the magnetic fields of the domains tend to revert back to the random state, and the motor, the magnet, loses its magnetism. What I want to do today is take an old magnet where the fields are now randomized, apply another magnetic field from a pair of magnets, and these will be neodymiums. If I put a north pole there and a south pole there, then the resulting lines of magnetic flux flowing through our motor's magnet will help to align it north to south, and help to align all of the domains. What I'm also going to do is tap the magnet, which encourages a bit more movement within the atoms within the domains, so that their magnetic fields align with the neodymium magnet fields. So here we have it reassembled again. Back to the ammeter. Let's see what it takes now. Now it started on, where did it start? Let's have a go. Started on 150 milliamps, more or less. I don't really want to go any faster than that, and it's taking a third of an amp. Opposite direction, at least it's starting by itself, and again it's taking about a third of an amp, which is significantly less than it was last time. Right, so now I'm going to try reassembling the motor, reassembling the model.